G'day there, you're watching the Aussie BIM Guru, and I thought I'd do a quick video today before I jump into my Dynamo for Python series to just cover a workflow I've had queried of me lately by a few followers, which has had a number things in a circle using Dynamo, and I'll use a pretty significant case study just to prove the workflow. So numbering by circle. So we've looked at the channel once on numbering by spline. So looking at the order that a spline goes near an element. Instead in this one, we're going to look at how we can collect elements, process their geometry, and then use their geometry to determine a circular logic to apply to them in a numbering sequence. So essentially taking a bunch of points, generating a circle around them or implying a circular environment they exist in, taking an arrow or a vector in this case, and essentially comparing the angles from each of those vectors in order to use an ordering function. So I've used this before in quite a lot of workflows, and it's a really handy little trick when you're looking at numbering things without having to draw a spline or something automatic. I'm not using any custom packages today, so it's a relatively easy workflow to replicate at home. You will need version 2.3 ideally. I think 2.0.3 in earlier builds should be fine as well. So without further ado, let's just jump into it. So I've got a project where I've set up a bunch of little workstations. So I'm gonna just minimize Dynamo. So I've got just a few workstation families I've built. You can use any families really, but what I'm gonna do is show you firstly how you can cluster families into little groups, because what I want to do in this case is treat each of these sets of workstations as their own sort of group, and then tell them which cluster they belong to. And I'm going to order them in a circular order, but as groups. So I'm going to show you first how you can group elements together using their geometry, and then also on top of that how we can create a function to number them as sets. So I think they're two quite handy techniques in Dynamo. So I'm just going to jump into Dynamo, and the first thing I'm going to do is just collect all these elements. So I'm just going to select model elements, and I'm just going to get all of those workstations. You could also use a family type collector in this case, but sometimes a select model elements is a good input for users so they can pick exactly what they want to number. So once we've got these, we're just going to move straight into Dynamo. What we're going to do first is we're going to get their bounding box, because we do need to process their geometry and find out which ones are right next to other ones. So I'm in automatic mode at the moment. That's probably quite important to notice. This script is usually easier to build in automatic mode because we'll be doing a lot of geometry, so we need to sort of review those things as we do them. So what we'll do is just use the bounding box to cuboid node, and what we should get is a bounding box for each of these families. So at the moment I've got some corner desks and some straight desks. So you can see roughly the bounding box that's cast around each of them. So for example here, I'll just move my geometry preview. So in this cluster, we've got a corner, straight, and straight. In this case, looks like it's not showing up because I believe it must be overlapping the bounding box. Or the bounding boxes might be out of order actually. That could be something. Yeah, the bounding boxes are out of order. So we're going to need to find out which ones are clumped together. And we're going to use their geometry to do this. So the first thing we're going to do is we're going to get a solid by union. So we'll just search for union, and we'll get this union by solids, because they're all cuboids at the moment, which is a solid. But what this will give us is just one solid, because cuboids don't have to be connected to each other. So we do need to find a way to break these apart into something that we can process. So what we're going to do in this case is we're going to intersect these cuboids. And this is a really handy trick that I use quite a lot, where you intersect a solid with a plane. So I'm going to intersect it with the XY plane because these are down sitting at 0 at the moment in my model. And what we'll be left with is a set of surfaces. But the great thing about this is that the intersection actually breaks them up. It doesn't keep them together as one big poly surface, even though they're not connected like the solid. So from here we can actually process this surface. So what I'll do is just hide my cuboids, and there you can see we're just left with individual surfaces for each workstation. You can see at the moment they're out of order, so we do need to find a way to order these. But what we're going to do in this case is we're going to have to find out which elements intersect with which surfaces. So we're going to have to do a geometry does intersect, and we're going to check which bounding boxes intersect, or which bounding box cuboids intersect which surfaces. I might just look for it in here, does intersect. Sometimes I find it really hard to find things in Dynamo. There we go. So we're checking if these cuboid bounding boxes intersect these surfaces. Now at the moment, we're only getting 8 results, which isn't what we want. We can do longest lacing, but it's still not quite what we want. What we want to do is cross-check every single bounding box against each surface once. So what we're going to do is work at level 2 of the list of our surfaces, so that for each of our surfaces back here, it reviews the entire list of other surfaces. And you can see that we're going to get one instance of true in each list, because each bounding box can only intersect one of those particular surfaces that it's generated. So we can actually use this to find the first index of true. So we can just get index of, and in each of those lists, and in this case we're going to work at level 2. We want to find the first index, so we're going to go level 2, and we're looking for the first index of the Boolean true. So this is essentially the index of the surface that correlates to that particular workstation in this case. So what we can do now is just use a group by key. So the way that group by key works is you take numbers or characters and it finds the commonality between them. So it'll find all the 1s, all the 2s, all the 3s, and then you can group another list based on those indexes. So if I go back and take my elements which generated these bounding boxes, which we intersected to our surfaces, we'll be able to group our workstations based on those keys. And you can see now these are all sorted by those keys as well. So we've essentially collected our workstations together, which is great. And we can really quickly just probably check one of these by probably getting their bounding boxes. So we could get the list at index 0, and we could really quickly, let's just get their bounding box again. So I'll go back and copy some nodes. We'll just go copy this bounding box and bounding box to cuboid. And you'll be able to see that we've collected a set of 3D bounding boxes that are connected together. And there you go. You can see that we've got a set. If I go to say number 5, you can see we've got a set. So in this case, we've collected our workstations. So now we just need to find a way to sort them in a circular order. So this is sort of where the topic of the video comes about. So what we're going to do is we're actually going to get the bounding box of each of those again to cuboid. And we're going to union. So we're going to get a union of these again. And what this will give us is a union for each sublist. So now what we're getting is a solid for each of these individual sets of workstations. The reason that we're doing this is we want to get the point at the center of this group of geometry. So we're going to get a centroid in this case, a centroid of the solid. And we'll get a point at the middle of each of these clusters. And we can use this as the point to check how far around on the circle this point occurs out of the whole lot. What we can also do is just union again. So we're going to union our union, because at the moment we've got 8 solids, 1 for each workstation. We just want to get one solid that represents all the workstation clusters. So it's a bit hard to see here, but we should have all 8 just as one connected solid. And then we can get the centroid of all of them. So we have our center point of our entire study. So we have the center of our circle and all the points around that circle as well. So we have what we need at this point. What we're going to do now is just form vectors. So we're going to form directions, because we're going to check the angle of a particular vector against each of the vectors to find the order that they occur in 0 to 360 degrees. So in this case, we're going to take our start point as our absolute center and our end points as the centroids of each of the workstation clusters. And you can see we get 8 vectors as a result, 1 for each cluster. What we need to do now is do an angle about axis for our vectors. So we need an angle about axis, and we're going to be comparing each of these vectors to a common vector. So in this case, we're just going to start with the y-axis. But what we want to do is have the ability to adjust the position of this y-axis. We don't want it to always be pointing directly up, because if we're doing it directly up, it's going to order them from counterclockwise at the moment, from the very top. So we may actually want to start, say, 90 degrees into that before we start numbering the workstations. So we're going to just call on a vector rotate so that we can rotate our vectors. So we need to input a vector, an axis that we rotated on, and the degrees. So we're going to put in our Y vector. We're going to rotate it about the Z axis so that we're just rotating it around the XY plane. And then we'll just add an integer slider. And for this slider, let's just say we're going to go from 0 to 360 with a step of 90. So the user can specify a 90-degree offset. And then once you move it, you'll find it sort of constrains itself. See that? Yep. So what we're going to do is, for now, we're just going to set it to 0. But we'll come back to this and show how we can impact the order of the numbering. So we've created this vector. So we'll just connect this up here. And then we also need to check the rotation of the vectors around the Z-axis again. So facing up, so that we're checking the rotation on the XY plane. And we'll get a list of numbers, and they should be a little bit out of order. Typically, you can see here they're not in order. So we can use these numbers again as keys. And in this case, we're not going to use group by key, we're going to use sort by key. So we'll just look for sort by key. And we're going to go all the way back, and we'll just move this out of our way, because we're going to sort those sublists of workstations. So it's a really handy little function managing things by key. I'll just might move this out of the way, just over here. So we're going to sort by the key of the angle of the center of those workdesk clusters. So you can see now we've sorted them based on their angle from that common point. And then each of these is now representing a cluster. So if we wanted to number these, say, cluster 1, cluster 2, cluster 3, cluster 4, we can literally just build a little function to do that. What I'm going to do first is just count how many workstations we actually have. So I'm just going to count my list and see how many we have. And in this case, we should have 8, and we do. We have 8 clusters of workstations, and I'm just going to build a little range. So I'm going to go from 1 up to count, or I'm just going to make a variable called C with a step of 1. And then if I connect this up, I'll get a range that actually responds to the number of workstations I'm dealing with. So you can see that I've got 1 through to 8, which is exactly what we want. We want to number them 1 through to 8. What I'm going to do is set this to the mark parameter, and the mark parameter expects text. So what I'm going to do is just do a string from object to convert this number to a string. And these look the same, but they're technically the string type now instead. So this will be accepted by the mark field. I want to have the option to reverse my ordering. So I may actually want to reverse the order that these groups appear. It's really easy to do that. We can just set up a list reverse. And what we'll do is we'll give the option for the user to toggle whether it's reversed or not. So we're going to use an if statement to do that. So we'll just call on the if node. And we can use the standard if node in this case, because the lists will be of equal length, because one is just the reversed list, essentially. So if true, when we do reverse it, we want to put in our reversed list. Otherwise, we'll say false is just our list in the order that it occurs. And we'll just add a boolean and say that this is currently set to false. And we'll just call this reversed. And if you're using Dynamo Player, you could just right-click this and just make it an input. Likewise, you could also come back here and make your select model elements an input. So you could say select families, because you may not just use this for workstations, you might use it for rooms or doors. There's a lot of possibilities for this type of workflow. What we might also do is just come and set this as an input as well and just say rotation offset, so that the user can offset that rotation starting point. And all that's left to do from there is set the parameter. So we're going to get an element set parameter node, set parameter by name. We do need to be careful of the levels that we're going to set these parameters at. So we'll just really quickly inspect these. So at the moment, we have a list of sets of workstations. So these sit at level 2. So we want to actually apply the same value to all 5 workstations in each list at level 2. So the elements we want to deal with at level 2. Now for this list, we want to set just this value here. So these occur at level 1. So we need to set it this way. If we don't set the level for the value, Instead, it will just apply the shortest lacing that it can match to the list at level 2. So each of these would then become 1, 2, 3, 4, 5, and then 1, 2. So obviously we don't want to do that. So we need to set our value to level 1 in this case. And we're pretty much good to go from there. We just need to set our parameter, which is mark. You could make that a string if you wanted to for Dynamo Player, so the user can type in the parameter name, say comment or a shared parameter. That's our parameter. This is our elements. And I'll just quickly save before I run this. And if we just connect this up, it should set the values right after that. So that should have just set all those parameter values. And we can see there that it's passing through all our elements, so it looks like it's been successful. If we jump in the model and just check these values, and I just check this one here, we can see this is 7, this is 8, so we can see 1, 2, so see that value there, 3, 4, 5, 6, 7, 8. So it's went around this way, anti-clockwise. If I just jump back into Dynamo and I reverse, we should expect it to go the other way, so clockwise. So you could actually call this clockwise. Maybe easier for the user to understand that by default, it will go clockwise if true. And now we should expect to go 1, 2, 3, 4, 5, 6, 7, 8. So we can see that that's how we can reverse the order by applying this if statement to reverse the list of elements. It's important to only reverse the lists or the keys, to not reverse both. Otherwise, you'll do the same thing essentially as not reversing it anyway. What we can also do is offset our rotation point. So let's apply an offset of 90. Now we should see that we're going to be going 1, 2, 3, 4. Yep, so now we're starting from here. So the rotation is being applied backwards. You could apply it, say you could go to 270 instead if you want to start from over here in this case. So that's how you could do like an offset of 90. You could reverse the number by -1 if you're finding that it's too confusing that the rotation's occurring backwards. So you could always just by default assume that the user is going to know that it's a clockwise rotation. But what we'll do is we'll say clockwise rotation. And then we will just take that and we'll just say v for vector times -1. So v is just a variable, it doesn't matter what it's called. And then we'll just reverse this. So we'll just say we want to go 90 degrees clockwise. And the user never has to know that this is sort of sitting here forcing it into a clockwise rotation. And now we should start at 1 here. So 1, 2, 3, 4, 5, 6, 7, 8. And obviously if you kept working this workflow through, you could even apply sub-numbering to each of these little clusters. I won't do it here because you've seen the general concept, but you could work with sublists and apply a rotational workstation numbering rule as well, or you could just number the workstations in order regardless of whether they're in a cluster or not. So it's quite a powerful workflow, and as we add more things to the equation, our script should be able to handle more things. You will get to a certain point where maybe circular logic isn't the right way to handle a numbering convention, but in a lot of cases this is a suitable convention to use. So if we go back here and we just select these new workstations, it should now run a new study and it can pick up all these new workstations. So in this case you can see it's probably going to get these first, then it's going to find this one, that one, that one. So you can see the order sort of becomes a little bit illogical eventually depending on how many layers back you're dealing with. But you can see just because of those levels that we set up in our formulas, in our parameters, so using levels, say like over here, and also back here, I think where we applied something at level 2, this allows us to just create more and more depth to the circular numbering system. So hopefully that's a useful technique and you'll find some use in it. One thing I use it for sometimes is to number rooms or to number doors in relation to their host room. So there's a lot of use in setting this. And unlike a numbering by spline, you don't have to draw the spline yourself. The circle is just implied by the location of the elements in Dynamo. So hopefully you found that useful. And the files for this one will be on GitHub when I upload this video. And I guess next week we'll be looking at Dynamo in Python. So just need to take a quick little break because obviously Python's quite intense on my brain as well. So I thought I'd just show this workflow because it's quite useful. But we'll see you next week for some Python in Dynamo. So thanks for watching. If you're not already following and subscribing, feel free to do so. I make videos about twice a week and plan to do so for a long time. So thanks for watching, and I'll see you in the next video. Take care. Bye.